Hello students, welcome back. Today we will be studying spectroscopy part 4, IR Spectral Analysis. So in this video, you will learn how to read the IR spectras and how to guess when the data is given of IR that signal indicates which peak. So let's begin. So students, let us understand what is IR spectroscopy. IR spectroscopy is a simple yet powerful technique in chemistry. Have you ever wondered what kind of bonds are there in the molecule? That's where the IR plays a role. So first of all, let us understand what is IR. So IR indicates infrared. So we are going to understand IR spectroscopy, which is a chemical analysis. It is used for chemical analysis that analyzes the interaction between the IR radiations and the matter or your molecule. And using IR, we can reveal the information of the structure and the composition of the molecule. Now, IR spectroscopy basically provides you the most important information about the presence of functional group, whether the functional groups are present or whether they are absent. Okay. But important thing of IR you have to remember is that only IR active molecules can be detected in IR spectroscopy. That means what? Not all covalent bonds can be displaced in IR spectrum. Means we cannot detect all bonds. Only few bonds which are polar. Okay, what do you mean by polar? Which can create positive and negative charge on them. So only those polar bonds gets detected in IR spectroscopy. For example, your carbon dioxide. Carbon dioxide molecule is IR inactive. We say that carbon dioxide gas is IR inactive. Now why it is IR inactive? The reason is it does not create polarity. Okay, carbon dioxide bond do not create any polarity because of its linear structure, that is this way. C double bond O, C double bond O. Being linear structure, the dipole moment of this molecule is 0. Okay, and that's the reason it is IR inactive. IR inactive. What does this indicate? Carbon dioxide gas we cannot detect in IR spectroscopy. Okay, so this sentence which I have shown in red is very important for detection of the molecules in IR spectra. That means what? All the molecules cannot be detected or all the functional groups cannot be detected in the IR spectroscopy. Only few which will show dipole moment will get detected in IR spectroscopy. So let us understand how to read the IR spectra. For example, you have given your sample for IR in IR spectroscopy for the spectrum to be detected. Now once you get the IR spectrum from the analysis lab, you have to read that. You have to read each and every peak whatever you have got. Now this is how the IR spectrum will look like. Okay. Now each peak in the IR spectrum indicates some value. Those are the wave numbers. So on the y-axis you can find the wave number. Okay. So for example, this peak, I'll just highlight it. This peak, it is 2986 centimeter inverse. Then the next one is 2652 centimeter inverse. Then the next one is 1715 centimeter inverse, and so on. Now, seeing the values, you have to detect which functional group it is representing. Now, either you have to learn those values or do the practice of reading the IR spectra using the chart. So, Once you do this, some of the values will be by heart by you, because there are many functional groups which are repeated in organic molecules. Now this is another IR spectra where you can see 3 readings: 1300 centimeter inverse, 2961 inverse, 1055 inverse. Now you may wonder how to recognize that which molecule these peaks belongs to. So let us begin. This is the IR chart. Now you have to go through this chart and I'll explain how these IR chart values represents the bond. For example, if you have the IR signal at 3500 to 3200, is between 3500 to 3200 centimeter inverse, then it indicates OH stretching of H bonds, which indicates functional group of alcohol or phenol. Okay, that means what? If you are having the signal between these values which are given here, then those represent OH stretching of either alcohol or phenol group. Okay, and what does this S and B indicates in the bracket? S and B indicates, S indicates strong, B indicates broad. That means phenol and your alcohol OH stretching will be strong and broad in the signal. That means I'll show you how. For example, if you have this IR spectra, okay, let me take this color. This is your IR spectra. Now this is how the OH bond will look like. If it is so broad, okay, this is how it is broad. But it is strong bond because we are getting a very strong bond, but it is broad. Okay, so if it is broad and strong, then and this value, if you find out the value, that is 3300 suppose centimeter inverse in your IR peak, then this will indicate OH stretching. Okay, this value will indicate what? OH stretching for either alcohol, because alcohol contains OH bond. Similarly, phenol also contains OH bond. So out of these two, this peak will indicate. Okay, so these are the small clues you will be getting after reading the IR spectra. The next is for NH stretching. Okay, that is amines, primary and secondary amides. See here, primary amine NH2, secondary amine NH. Okay, and amide, again amide is NH, CO, CONH. So this NH of amide and amine, primary amine and secondary amine, those stretchings will be seen at these values, that is 3400 to 3250, and that is M indicates medium. So if your signal is medium, okay, this way something, and if the value here comes out to be, suppose it comes out to be 3357. Okay, so this may be, you have to guess whether it is for NH, because this value comes between first value also, that is this value, okay, as well as this value. Then you have to guess seeing the signal, whether it is broad, strong, or whether it is medium. Okay, from that signals you can guess whether it is amines or OH. Similarly, next 3300 to 2500 centimeter inverse. Now again it is medium. It is showing OH stretching for carboxylic acids. So carboxylic acids OH, that is this one. Okay, C double bond O, OH. So in this carboxylic acid, then there is again a OH group. So this OH group will be, it will show the signal in between 3300 to 2500 centimeter inverse. Okay, so this way we can distinguish between the OH of alcohol, OH of phenol, OH of carboxylic acid, and so on. Okay, so seeing at the signal, we have to guess which OH it belongs to, which OH the stretching belongs to. Now next is 3300 to 3270. N indicates narrow, S indicates strong. So the signal may be strong but it is narrow. If such is the case, then it may be because of what? It may be because of triple bond CH and CH stretching of alkynes. Those alkynes which are terminal. Terminal indicates these type. Let me take yellow color. Yeah. So these type of alkynes. So here is R group. Now this will be called as terminal alkyne. Terminal. So this CH bond will show signal between what? What they have shown here, between 3300 till 3270. Similarly, 3100 till 300, 3000, 3100 till 3000, a strong bond if you get, then it indicates CH stretching for aromatic rings. Okay, for aromatic rings you will always find the stretchings at 3100 till 3000. Similarly, there is 3100 to 3000 but medium, the signal is medium, it indicates double bond CH stretching of alkenes. Then 3000 to 2080, 850, medium CH stretching of alkenes. Similarly, 2832 to 2695, medium, it will indicate CH stretching for aldehydes. Okay, so few of these you have to remember, like you have to remember the aldehydes one, then aromatic rings, carboxylic acid, amides, phenols. These are important. You have to remember them. You have to learn them by heart. Okay. Similarly, for nitriles, that is cyanide stretching, CN stretching. Nitrile indicates C triple bond N stretching. Okay. It is between 2260 till 2210. Then V indicates what? We will be indicating your signal. Similarly, 2260 to 2100, again a wide, W is weak, which indicates triple bond, CC triple bond of alkynes. Okay, so out of this important are alcohol, phenol, amide, carboxylic acid, aromatic ring, aldehyde stretching, nitrile stretching. Remember this, student. And only one way to remember these signals are doing the practice of numericals. When you do the practice of numericals, automatically these get by heart. So next is 760 to 1665. Strong peak you can get for carbonyl stretching. Okay, general carbonyl stretching. Similarly, 1760 to 1690, strong CO bond, that is C double O bond stretching. It is because of carboxylic acid. Then 1750 to 1735, again this stretching is for esters and saturated aliphatic aldehydes. Then 1740 to 1720, aldehyde and saturated aliphatic rings. So you can find, mostly you will find these all, you have to have the guesswork that carbonyl group shows the stretching from 1660 till 1710. Okay, these are this is its range for carbonyl. Either it may be the carbonyl of ketone, ester. Okay, for ester C double bond OR. So it may be for ester, it may be for ketone, it may be a general carbonyl group. So all these carbonyl groups shows the stretching from 1710 till 1665. So this way you have to remember. Then alkenes C double bond C stretching shows between 1680 to 1640. NH bending is between 1650 to 1580. Okay, that is for a primary amine. Then for aromatic ring, this you have to remember, students, it is between 1600 to 1585. Okay. Similarly, for aromatic rings, CC, single bond stretchings in a ring, that is again from 1500 to 1400 medium. So there are few important which you have to remember. Alkenes also you can remember for double bonds. Then normal alkanes, that is CH bending, it shows from 1470 to 1450. Then CH rock indicates rocking, okay, in the plane bending. So it is from 1370 to 1350 for alkanes. Then nitro groups also shows the symmetric stretching between 1360 to 1290. CN stretching of aromatic amines between 1335 to 1250, and so on. So this way, using chart, you can just try to guess what are the peaks you will be you have got in your spectra. Okay. Now let us go to the next part. Important signals we will just discuss just now. Aromatic ring, aldehyde, okay. Alkenes with this. Carboxylic acid you have to remember, because many a times the examples are based on carboxylic acids, phenols, alcohol. Okay, so it is from 950 to 910. So OH bending is there for carboxylic acid. Similarly, aromatic, you will see the what is this OOP. OOP is nothing but out of the plane. Okay, when out of the plane, CS stretching is there for aromatic rings. It is between 900 to 675. So most of the numericals you will find 710, 725, such readings are given of IR, which always indicates aromatic ring. Okay, such always indicates aromatic ring because of CH stretching. These stretching shows these reading from 900 to 675. Then what is important among these? Okay, aldehydes also, they are not asked many times, but you should know. Whenever there is aldehyde stretching, it is again between 850 to 550 for chloride. For bromide, it is 690 to 515. So now let us understand the chart. Okay, whatever IR spectra is given, for example, if you get such type of IR spectra, let us understand for which molecule it may be. I have already shown on the screen the molecule also. So let us understand the each signal of IR. For example, you are getting the signal at 2986. So 2986, this is the signal which is showing at 2986 centimeter inverse. So it indicates OH stretching. Okay, either it may be for alcohol or acid, carboxylic acid. So next is 2652, that is hydrogen bond dimer. Dimer indicates that it is formed, two molecules are forming dimers. Okay, two monomers are attached together, they are called as dimer. Then CR 1715, this is always for carboxylic acid C double bond O. Okay, carboxylic acid C double bond O. Then 1415 indicate COH stretching. COH stretching. Then 1240 indicates CO stretching. 1240 indicates CO stretching. 937 indicates OH bending. 937 indicates OH bending. Okay. So these, using this we can find out which are the groups or functional group present in your molecule. So only one thing we can guess is it contains a carboxylic acid group. Okay, because whatever peaks we have got from IR peaks, we can only guess the functional groups. Functional groups. Okay, students, we can guess the functional groups. So here the functional groups we can guess is that the IR spectra indicates that the molecule may contain carboxylic acid, that is C double bond O OH group from the stretchings. Okay, so let us see the next one. Next IR spectra, you can see there are only three signals we can see. Main three signals. There are small peaks, but if you see, there are three signals which they have indicated here. Now these three signals, if you see the first one, 3300 centimeter inverse, and it is a broad peak. Students, whenever you see such a broad peak near between 3000 to 3500, you should always remember that it indicates the OH stretching of either alcohol or phenol. Okay, it is a OH stretching either for alcoholic group or phenolic group. Then 2961 centimeter inverse, this will indicate for your CH stretching. Okay, this is for OH bending. So this way you can just guess what are the groups present. We cannot, from IR spectra, we cannot directly guess we cannot determine the structure. Okay, we can partly determine what are the groups present from the IR spectra. To determine the structure, already I have made one video. You can go through that video of elucidating the structure, that is to determine the structure using IR, UV and NMR spectra. So whenever you have to determine the structure, what structure is present in your given molecule, you have to analyze using these all different techniques of spectroscopy. Either it may be IR, UV, NMR, mass spectroscopy. So together collectively we can guess the structure or elucidate the structure when we have all the data. That is, you should have the data of UV, you should have the data of IR spectroscopy, NMR spectroscopy, mass spectroscopy, then only we can guess the structure. Okay students, so from IR spectra we can only guess the functional groups. So I hope you have understood how to guess the signals and how to understand which functional group is present in the given signal from IR spectroscopy. Use the chart and solve the problem based on IR spectroscopy so that the signals will be by heart with you, to you, and you can solve the numericals based on IR spectroscopy. Okay, so best of luck for your exam. Till then, take care and do watch my next videos on spectroscopy. Till then, bye, take care.